Chapter 2, Section 2.2. The rest of the notes here, I'm going to talk about the intermediate value theorem. So the intermediate value theorem says if you have 2 points that are at different heights, so your y values aren't equal, then your graph, is going to be rising or falling from point to point, maybe doing some of each. You are going to have every y value in between for accounted for in your interval. So here's a nice picture of it. If you have an A value and a B value and you have some height there at the A value, some height there at the B value, when you go from A to B, every height between these two heights will be covered. So if you pick a height in those heights, there will be a point on the graph, some x value between A and B for every height. So here's an example. I have some polynomial, and it says, use the intermediate value theorem to approximate a real zero. So what we're going to do is just start to explore what this function has going on. So I picked just some of my standard x values and started plugging them in, and it looks like our y values surround 0 right here. So in my case, I have A is -1, B is 0. Those are my x values. And they, f of -1 is negative, and f of 0 is 1. It's positive. So negative number, positive number. If you go between -1 and 0 on your x-axis, the y values go from -1 and 1. And so in between there somewhere, there has to be at least one height of 0 at least one x value. So if we zoom in and start checking, the tenths between -1 and 0, we start to see like at -0.8, that's my y value. It's a little bit negative. At -0.7, it's a little bit positive. So we know that the real zero, the real x value where there's a 0, is going to be between -0.8 and -0.7. If you zoom in even more, you can see that it's at -0.755. Graphically, you can see that 0 right there.